Hello everybody, thank you very much for joining us. Today we are interviewing Simon Ponting from the Weir Group up in Scotland. This is in line with the live interviews for our If You Were an Engineer, What Would You Do? Leaders Award project, which hopefully you're all getting on with by now and enjoying yourselves while completing the project. We're here to look for the inspiring engineers of tomorrow, and Simon's presentation here is going to run through his career and how he got to where he is now and in the engineering industry. And hopefully this is going to inspire you to come up with your own amazing designs, which, by the way, we would need by the 23rd of March, which is next Wednesday. There's plenty coming through the door already, so if you need any assistance with that, please call us on 01282 417 333. And what we'll do, Simon will go through his presentation, and then following that, we will have a Q&A section. So please remember to get your questions ready and pop it in the chat box, and then we'll run through as many as we can. So over to you now, Simon. Thank you.
Brilliant. Thank you very much, Josh. So I'll just start the presentation. So hello, good morning, I suppose. My name is, like Josh said, Simon. I'll be talking to you today a little bit about engineering, what engineering is, how I got into engineering, and what I do on a daily basis. Feel free to, I can't actually see the chat box because I'm sharing my screen, so we'll do questions at the end. I think Josh can interview me a bit as well, so just save any questions you have for then. So to make it start, the definition of an engineer. So what is an engineer? It's a big word. What does it actually mean? So an engineer is someone who uses their scientific understanding of the natural world and uses it to invent, design, and build things, solve problems, and achieve practical goals. Now, that's a lot of words. Basically, the key words at the end there are solves problems. So an engineer is someone who solves problems. We look at all types of using maths and science to fix any little problem that you could think of, small ones and big ones. So engineers don't just solve one problem and then it's finished. They're always developing things and continuously improving old things. So if you had a problem which is as broad as how can I get to my destination quickly? A solution would be a car. Now, if you showed up with one of these cars these days, you wouldn't be, I mean, people would see it as retro and think it's great, but it's not the best car, is it nowadays? So because engineers have continued to design and improve what already exists, we now have cars that are a lot safer, a lot faster, a lot more efficient than we did, say, 50 years ago. Similar thing with a plane. How can I go to another country being the broad problem? A ship or a plane would be a solution. But if you went to the airport to go on holiday and the pilot was in one of these planes, I don't think any of us would get on these days because we're just so used to how engineers have improved planes to be more, again, safer, efficient, and carry more passengers and all this sort of thing. Old cars that have been improved into newer cars, and then again, this is the picture of the plane that I wouldn't get on, and then, you know, more improved cars, planes even. So then another problem which engineers could broadly talk about is how could I speak to someone else who's not next to me? So other side of the world, other side of the country. 50 years ago, you'd probably have to write a letter or maybe even use a telephone that looked like this. But because engineers have continuously improved everything, phones and all that sort of things, now most people have a smartphone where they can speak to anyone in the world using an array of different texts or Facebook, or even call them up and speak to them in person, FaceTime. All of this has been just improved. And when you look back to it, the simple problem is, how can I speak to someone who's not near me? So there are many different types of engineers as well. So I'm just going to take a car as an example and show you different types of engineers that have been involved in making and designing of a car. So you've got mechanical engineers who they'll look at the exterior. So they'll look at the aerodynamics, the things that move inside, like the engine and the wheels and all the actual body of the car, how that works and how that can work better. You've then got chemical engineers. Now these look at, they can look at materials, specifically plastics, and they look at the makeup of petrol. So how having a different makeup of petrol can make your car more efficient, make it run better. That's what a chemical engineer would do. And then a civil engineer will look at the bridges and the roads and tall buildings that cars use all the time. Maybe not the buildings, but the bridges they use. They also look at any sort of structure is like a structural or a civil engineer. You then have software and electrical engineers. So your sat nav is your basic example, but cars are quite clever now. So they've got little onboard computers. You can have all sorts of things that a computer does, and electrical engineers work out the programming and the actual physical little circuit boards that make up all the electrics inside a car. So you can see that loads of different types of engineers can be involved in one big project just to make a car. And each engineer basically does the same thing. They just solve problems, but they have certain expertise in certain kinds of problems, which helps them in the areas that they look at. So a little bit more about me and how I became an engineer. So like I said, my name's Simon. I'm 27 years old and I work as a design engineer, mechanical design engineer for Weir Minerals. So my job is to design process equipment for the mining industry. Now I'll come on to that a little bit more later because that sounds big and fancy, but why did I become an engineer? So when I was younger, about your age, I used to love playing with toys like Connect and Lego, taking things apart, building things, seeing how they all worked was really cool to me. I once made a little wooden tank with my granddad that I've still got to this day. Just making things like that was just what I enjoyed doing all the time. So then at school, my favorite subjects are maths and science. It sounds a bit nerdy, but they were just what I was good at. Not very good at English really. So maths and science were what I preferred doing. So when I got to do work experience later on in school, my dad suggested I go to an engineering company. Now they built parts that went on fighter jets, which I thought was really cool at the time. And then when I worked there for a week, I thought it was brilliant. So I was sat with someone who's designing something on a screen. I'd see what they were designing. They'd teach me how it worked, what it would do. And then they say, right, now go downstairs and see one of them built. So they show me what I'd just seen on a screen downstairs on the shop floor. And I could actually touch and see what they designed and built and how it would work and see how it would fit onto a fighter jet. I thought that was great. How, that would just be such a cool job to do. So after that, went back to school, finished my A-levels. And then I went to university in Huddersfield to do mechanical engineering. Whilst I was at university, they taught me everything I needed to know about being an engineer. So I learned about materials, aerodynamics, and computer-aided design. One of the main things I did there was spend 1.5 years working as a trainee engineer in an oil and gas company who make things that sit on the bottom of the seabed that look a little bit like this. So you can imagine that things on the bottom of the sea don't really last very long. They're very difficult to get there. You can't just go and plug it in yourself down there on the bottom of the sea. So this was really interesting to me just to see how a group of engineers and a group of people could come up with ideas and make things work in such a hostile sort of place that I'd never seen before. So after I did that, it was midway through university. So I came back to university, finished my degree, and then got a job at Weir Minerals where I design mining equipment such as this, which I'll talk about in a little bit more later. So one of the favorite things that I did whilst at university was we did a group project to build a drone. This was a big group project which started for a full year. We'd looked at all the parts we made, designed and put together ourselves. This was part of a competition with 14 other teams, so we did come third overall when we finished. But this was a mix of electrical and mechanical engineering. So I'm mechanical, so I did most of the outside structures here, and we were looking at that. And then we had a team of electrical guys doing all sort of the wires and the circuit boards and batteries inside to make it all work. So we gave them a structure that would fly, and they gave us the brains inside that would make it fly. This worked automatically as well, the way they did it. So we could take off on its own, fly to a point, drop, land, take off again, and fly back to the first point all by itself. I really enjoyed doing this project. It was so much fun just to sit work on this all day, doing what we wanted to do. We weren't really supervised to do it. We just had to do it, get on with it. And it was great fun. Really enjoyed doing that. So then what is my job now? So to break it down, when we dig rock out of the ground, so if you pick up a pile of mud from your garden, you've got bits of grass, you've got bits of rock, bits of mud, whatever, bits of tree root, bits of leaf, anything in there. This is the same in a big mine. So you want something out of there. So it's probably a metal or gold, but it's in and amongst a load of stuff that you don't want, like gravel, rock, whatever. So there's a number of different stages to break down all of this stuff and sort out what you want. And that's what we do. So you've got a big dump truck here, which is the biggest dump truck you've ever seen. And that's just a tiny little speck really on the whole of this little mine site that we supply most of the equipment for. So the rock will come in here and then it gets traveled along and crushed so that it's a lot smaller and easier to manage. And then my piece of equipment is up here, this circular thing up here. And this is used to separate different sizes of pieces of rock that you want and don't want. And it's called a cyclone. So basically what you do is you throw in or you pump in a mix of water and rock that you want and the rock that you don't want. And then it sorts things out via how heavy it is, not the size of it. So if you think of a bowling ball and a football, they're roughly the same size, but they weigh totally different amounts. You wouldn't want to kick a bowling ball. So this is similar. You've got rocks that are really heavy and dense, ones that are really light and sort of airy. So the heavy, you basically pump in the mixture here, and the shape of it means that all the heavy stuff and the bowling balls would come out the bottom, and your lighter stuff, so your gold and your metal or your football, would come out at the top. Then we put a load of these in a circle and call that cyclone cluster, which is what I mainly work on, which is one of these things. So just to give you a few more examples of how big these are and what they actually look like. This is me stood next to one. I'm sat down now, but I'm roughly 6'1"-ish. And that's how tall this bottom tank is. So you can see that these are about 5 meters tall, absolutely huge. Some of them can be, and they're sorting out really small particles that are about 1 millimeter in width. So this is a similar example, just another one that's same height as this previous one, but it's just a lot more of the same cyclones. I think there's about 20 in one circle here, so it was really quite a big thing to move around. There are some little ones that look like toys. These are a lot smaller, but they that one's only about 6 foot tall itself, the whole thing. But they just sort out different sizes of particles. When things are on site, they will look all clean and shiny when they're built, but when they've been on site for a couple of hours, there's a lot of splashing and muck in the air, so they start to not look quite as clean. Then this is the main part of my job. So we create a fancy 3D model, effectively, of using computer-aided design software of what we want the customer to have. So the customer will come to us and say, we've dug up a piece of rock that looks like this, and we want this out of it. What can you do? So then we take that information, we do some calculations, and use our fancy computer software to design a 3D model that looks like this one at the top. Now that's great because it's in a computer and we can show the customer what we want to do, but then people have actually got to make what we've designed on the computer screen. Now this is sort of the tricky bit and the fun bit at the same time. So we use things called technical drawings, which look a little bit like this. So you take a snapshot of the cyclone or the cluster at a certain point, and you dimension it up so that people know how big that bit should be at that point and what it should look like with something they can measure against, so that they can go away and they can build what you've designed. Now, as I showed you the full mine site, that's what we do as a whole. I'm involved in one little part, but I've also done other projects where it's called a valve body. But the cool thing about this was I got to use a 3D printer. So we use the fancy 3D computer software to have a model of the part that we were looking at. We then analysed it by simulating forces that were acting on it and how it would actually operate if it was in real life. Then once we thought that that was going to work okay, we used a 3D printer to print a test model of what we designed on the computer. And then we got to send that test model to be tested physically to show that it could do exactly what the computer had said it would do. This was a really fun project to do, and just shows something different aspects that are involved in every engineer's job. You know, you don't just do one thing, you do multiple different things. That's it from me, presentation wise. So I'm happy to take any questions that you've got about me, engineering in general, how to get into engineering, and just any questions you've got, really. Thank you.
Brilliant. Thank you very much, Simon. That was great. That was very informative and interesting. We've got some questions coming through now, so we'll begin. We have the first one. How did you get things to the bottom of the sea?
The answer is really, you use a really long rope, but not quite a rope. So you have, I've got this here, the pictures there. You have a big boat, like a big ship that has a big hole in the middle, a big square hole in the middle of it, and you have a big crane that just drops it down. You have the boat's quite a special boat, so it'll have a lot of little engines that are keeping it stable and in the right place. But then you use these little robot ROVs, they're called, remotely operated vehicles, and they have little claws on it, and they guide it all the way down and make sure that it's in the right place when it gets to the bottom of the sea.
Okay, so just so we can get an idea of scale, the item at the bottom of the sea, how big would you say that is?
Well, so if the scale might be better, if you look at these little remote operated things here with the lights on, that's basically the size of a car. So I would say that's about the size of a double garage, something like that. They're not small, they're quite big things. I know the scale's a bit off, but yeah.
No problem. And the next question links nicely to that one as well. So have you been to the bottom of the sea?
No, unfortunately not. That would be very cool. We do get to go to see the stuff that we've installed, but when it's at the bottom of the sea, it's very expensive to put there. So they only spend money on the people that can actually do it. So I haven't been to the bottom of the sea, no. Good question.
Brilliant. So did you like maths and science in primary school as well?
I did, yes. So primary school was probably science more than maths. You know, the little experiments you do at primary school are much more fun. Maths gets a lot better as you get older, when you can understand more than just adding up. But it's, yeah, so I'd say science more than maths at primary school for sure.
Perfect, brilliant. And going back to the drone project that we saw a slide of, how far could your drone fly and how long did it take to build?
So it probably took us 6 months to build. To design it, to know what we wanted to build was a month or two, then to buy the parts, and then was another month, then to make it all working was sort of another two months. How far could it fly? It runs on batteries, similar to a remote control car, so it would fly as far as the batteries would last, really. And the ones we had probably lasted about 20 minutes. So as long as you're fairly close to it, it could go really high and the signal would last for ages, further than a remote control car. But yeah, about 20 minutes it would fly for.
Perfect. So it was quite a lengthy project, but I'm sure it was very rewarding for yourself and the team once complete.
Yeah. Well, I mean, it was a year-long project. We had to do it as part of our final year of uni, so we had to make it last the year as well. We couldn't just finish it in a couple of months and say we're done, because they expected it to last that long.
Yeah.
But yeah, it was really fun to do. We've got to go away for a weekend and fly in a competition, which was just really good fun.
Brilliant. So we've got a question here from Year 6 Holy Trinity. What would you be if you weren't an engineer?
Oh, that's a great question. I don't know if I wasn't an engineer, to be honest. I like sports a lot, so I like watching and playing football and rugby. So I'd love to do something like that, but I'm probably not good enough for anything like that. I've always liked sort of science. Before it was engineering, it was maybe, working in a lab or something like that. Maybe a bit more more scientific than engineering. Something like that would probably be good fun for me.
Perfect, brilliant. I like this question as well. So, are there minerals in space?
There are loads of minerals in space, yeah. So you think of, we're digging up the Earth, which is made of rock. The Moon and most of the planets are exactly the same. They're all made up of rock as well. So we've had conversations in work about mining things on the Moon and different planets and things, but it's just very difficult to get it all back at the moment. That seems to be the problem. I think one day, I think something like that will exist. Yeah.
Perfect. And another question from King Lassie, P5. What problem do you think would be the most important we could solve?
There's a few that are big at the moment. I think when we look at the car, you can broaden it down to how do I travel somewhere? That's a really broad problem that has really narrow answers. Like it could be a horse, a car, a plane. So I don't think there's always one solution to it, but I think energy is a big problem, I would say, at the moment. How do we create enough energy for people to live with electricity the way they do at the moment would be one for me.
Perfect. I couldn't agree more. King Lassie, P5 with the second question. What is your favourite part of the job?
Favorite part. It is a part, but it develops. So I really love seeing what I've designed on a computer come to life. So I really like designing it on a computer, and then seeing that in real life is definitely the best bit.
Brilliant. Next question we have, Year 6 Holy Trinity. This is from Liam. What do you do when you make mistakes?
That's a good question, Liam, because it happens. It does happen. I'm quite young. I've only been an engineer. I've been in the job for 4.5 years. So if I make a mistake, my boss normally catches it before it is turned into a big mistake. So at the moment, I feel bad and get told that I'm still learning and that it doesn't matter. But you just have to take on board what you've made a mistake in and try not to do the same thing again. The other thing is, if there's been a mistake made and something's been made, that's when your engineering kicks in. You've then got a new problem that you have to solve. So you just have slightly more restrictions, and you sort of have to go, okay, well, this has been made this way. We can't spend much more money on it, but we need to fix it. So how do we do it? So you almost start the engineering process again with the problem.
Perfect, brilliant. I think you touched on a nice point there as well. So making mistakes is part of engineering, and this is how you learn and grow.
Yeah.
So this is how you develop the skills.
Yeah, definitely. You almost have to make mistakes to be able to know that you can change it. Nothing is designed perfectly the first time. It goes back to that sort of continuous improvement. You think of a car, if they'd have gone, right, that's the car, brilliant, we're done, we can move on 4 wheels now, we don't need to look at it again. Where would we be? So yeah, definitely.
Perfect. So we got again King Lassie, P5. Have you ever been hurt during your job?
Hurt? It does happen. These are big bits of equipment that are being moved around, especially when they're being built. I haven't personally been hurt badly. I might have cut my finger on something or anything like that. But there's a lot of health and safety involved in this sort of work. We have to wear, I've got some here, we have to wear high vises whenever we walk around sites so that we don't get run over by forklift trucks and things like that. Anyone that's doing any particularly strenuous work has to have training on how to do that work properly so that it's done safely. So, I mean, accidents do happen, but no, I've not been hurt because of the safety that we do have.
Brilliant. That's good to hear. And have you ever made a tank?
Only the little wooden one, unfortunately. Made a few out of Lego and things with my nephew recently, but no, I'd love to do something like that one day. But they're just so big projects. So you need such a big. This drone wasn't very big, and there was about 13 of us on it. I don't know how many people you need on a project to make a tank. It must be a huge team.
Perfect. And just going back to when you mentioned that you played a lot with Connect and Lego, did you think that's where your engineering mind started to kick in? And what age was that when you started thinking about the building of things?
I think I was probably quite young. I remember being about 7 and getting a big Connect kit for like a wind up and pull back car. Yeah, about the age of 7, I remember really enjoying putting that together and doing it, and just seeing it work. And then, yeah, taking it apart, doing it again, making it look slightly different. So yeah, probably around that age, really. But then my mum says that when I was sort of 2 and 3, I was always using building blocks, playing with, Duplo, the smaller type of Lego and stuff. I obviously can't quite remember that as well, but yeah, apparently I've been always doing it.
Perfect. But I think that's a common thing with, especially with the interviews that we've done over the course of the project. A lot of people have mentioned Lego, Connect, things like that when they were younger. So I think it's really great to notice that a lot of people today are probably thinking like an engineer without even knowing it at the moment.
Yeah. We all. Weird thing is, we all do engineering all the time. Luckily, it's my job, and I get sort of paid to do it. But you'll do it all the time. Stupid little things like if you get a hole in your football boots and you tape it up, that's fixing a problem, that's solving it, that's engineering. All these tiny little things that you do, it is just sort of a mindset, and then it can turn into loads and loads of different jobs when you get older.
Perfect, brilliant. So we have a question here from King Lass AP5. Are you passionate about helping the environment?
I am, yes, because I think it's a big problem. It might sound hypocritical, I suppose, saying that in the mining industry where we're digging up the earth to use it, but we do it in such a way that we're using as little energy as possible and doing it as safely and as sustainably as we can. And that's definitely something that I was taught at university. Some of the older guys here aren't quite as passionate about it as I am, but yeah, definitely, we really need to find better ways of doing things, because we've got ways of doing things now but we just need to improve it so that it's more sustainable and the planet lasts longer, because we're slowly but surely running out of resources.
Definitely, yeah. And if we all do our little bit, it can go a long way, make a big impact.
Yeah, definitely. Yeah.
So, going back to the creating of things, what is the easiest thing we could create that you think that doesn't already exist, which is actually linked very nicely to the Leaders Award project?
Yes, it is, yeah. That you could make.
What would your invention be?
When I think of inventions, I always think of things that would make my life easier. What would stop me having to do things? What would help me? So I haven't got a good invention, because if I did, I'd probably be working on it. I like looking at things like if like even small problems. If I had something stuck, like I was playing with football with my nephew recently, and the ball goes underneath the car, and I've got to try and hook it over with my leg. Like, could I make something that fits in my pocket that I can pull out, and then I can hook a ball away from underneath the car? You know, little things like that. Nothing that's going to change the world, but just every little inconvenience you can think of. What could you potentially do that could stop that being an inconvenience?
Fantastic, perfect. And what's the weirdest thing you've been asked to make?
The weirdest thing. I had to do, I haven't got a picture of it here. I had to do at university a project for a guy who he really enjoyed running, but he couldn't run properly. He had a stroke when he was younger. So I had to design something to put on the bottom of his shoe to stop his shoes wearing out. So it was a bit of a weird request to start with, but when you looked into it, it was really good fun to do, because he was ran in such a way that he was just thumping the top of his shoes, so he was wearing out his shoes really quickly. He was having to buy new ones all the time. So he said, "Do you mind trying to design something that, you know, using the right materials, the right shape to match my foot, for his foot personally on the area he was wearing out, how to stop that working." So that was a weird one. That turned out to be good fun.
Perfect. It usually is the case, and you'll never forget that one.
No, and he was a really nice guy. You know, I got to speak to him and help him throughout it. So yeah, it was great fun. Yeah.
Brilliant. So we have a question here from Elise, Year 6, Holy Trinity. How much does an engineer earn?
We, depending on what you are, so my boss obviously earns a bit more than me, but at the moment we earn between 30 and 40,000 pounds a year, I'd say.
And that increases, is that the starting from university, or does that increase over time?
From university is probably from 25 to 30, and then after a few years that changes up to 30 to 40, and then I think my boss is on, I don't know what I'm on, to be honest, but I would say more than that.
Perfect, brilliant. So going back to teamwork, how important is teamwork in engineering?
It's vital, because a few things, you know, going back to making a mistake. If you've got someone working with you, they can spot that mistake. You can think something's the best thing in the world, but somebody else might say it slightly differently and help improve it. And everyone's got different skills. So this sort of drone project, we had some guys that had been training to be an electrical engineer for 4 years, and I'd been training to be a mechanical engineer for 4 years. So they had very different skills and different understandings than I did. So I needed them to help the whole project work as a whole. So yeah, it's a team sport, I'd say. Engineering, everyone brings their own part, and you need the individuals, but yeah, it definitely helps being part of a team.
Perfect, brilliant. And how many people do you work with?
So in my team, there's 6 of us underneath my boss, but in our department, we have some guys that do some of the admin as well, in the engineering team, and a few other different teams. There's probably about 30 of us in the department, but my direct team that I speak to sort of on a daily basis is about 6 of us.
Brilliant. And from your experience, would you say it's quite important to have a little bit of a focus on female representation in engineering?
Yes, yeah. There's not enough female engineers. We're talking about team working and different perspectives. Having female perspectives would change the industry, to be honest. It's quite male orientated at the moment. I think that's just because it's how it's been for years. But if the female engineers that I know are fantastic, and they bring so much to the team, often a lot more than some of the men, just because they just have better perspectives on things. They're just really, because they're different, they're seen as different. They shouldn't be, but they just change the environment a lot. And it's fantastic to have female engineers.
Definitely. I think that is improving, and hopefully we've got some female engineers watching today.
Yeah, I mean, I went to university with a couple on our course, and they're doing a lot better than most of the men, because they just, they have the creative mindset and work ethic. So yeah.
Brilliant. Girl power. I love it.
Yeah.
So just another question about the drone here. What problems did you have to overcome while building the drone?
One of the main ones was the weight of it. So we had a limit that, because it's a drone, if it weighs over 7 kilograms, it's technically classed as a light aircraft, and you have to have a special license to fly it. So we had to get all of the kit inside of it and all the whole of the body to make sure that it weighed under 7 kilograms. And that was probably the biggest challenge. That's why you can see we've got big holes in the metal arms, because they were too heavy. So we had to just take away as much material as we could. And that's why the top is carbon fiber, because it just needs to be as light as possible.
Perfect, brilliant. King Lassie again coming in with plenty of questions. Thank you. So, what project are you working on right now?
So I'm working on something similar to this Cyclone cluster at the moment, but it's a very big one at the moment. So the site there's one existing on the site that's been working for a couple of years, but it's not the best. And they've come to us and said, can we have a better one? So I have to make it fit in exactly the same space, but improve what's already there, which is proving difficult at the moment, just because of how small everything. The space that's existing is proving difficult, but it's good fun and a good challenge, definitely.
Brilliant. Well, I hope it goes well. Is there a project you haven't enjoyed?
Yeah, there are some. Not because I don't enjoy the engineering work, because the engineering work's always the fun bit. Sometimes it can be I suppose, politics around things. So my boss gives me a sheet that says, this is what they want. Now, if the customer doesn't know what they want, or they think they want this, but they might want this, or we suggest something and they don't like that suggestion, they want something else, that's when it can be a bit more of a pain. But again, it's just solving problems. So you just sort of have to take what the customer wants, because the customer's king, like with every business. If they want it, they can have it, but it just means that we're going to spend a bit more time engineering it.
Fantastic. So we'll do a couple more questions now before we finish.
Oh, those. Great.
Yeah, we've got plenty coming through. How long does it take to build a Cyclone cluster?
So the projects last about 6 months. It will take me and the team probably about a month and a half to design it. So about 6 weeks to fully complete it. And then it will take maybe about a month to build everything. And then it could take 2 weeks to ship it to where it needs to be. So we could make them in the UK, and then they go to a site in Turkey. And it's expensive to fly it by plane. So you put it on the back of a wagon, and the wagon might take sort of a week to get to where it needs to be, and then it needs to be installed. So roughly about maybe 6 to 8 months from start to finish.
Brilliant. And do you use specialized tools for that?
Yes, so a lot of it's welded together. These the big tanks, these effectively, just like a big sink, really. They just collect what's coming out the bottom. So they use special tools for the welding part of it. We also do something called rubber lining. So you can see that there's a red part of the pipe here. It means that we have a piece of metal, and then we cover it in rubber, so that the rubber wears out but the metal doesn't. And that's not a lot of industries use that, so there's quite few niche sort of specific tools that we use to make those particular parts. Yeah.
Fantastic. And I like this one again from King Lassie P5. Have you ever created something useless?
Yes, lots. We've got a lot of things that can be done for sort of visual purposes. I suppose I can't see what you can see at the moment because I'm on this screen, but we've got, this is a 3D printed version of a Cyclone. Other than to look at, because it's got a big hole in it, it's pretty useless. But they're the sort of things that can be quite useful. In fact, I'll just stop sharing again. So yeah, there's no real purpose other than it just looks good. So I suppose that's pointless, but it can show us how it could work, what the inside of a Cyclone actually looks like, things like that. So there are little purposes for training and things, but yeah, there's a lot of things like that that can just be.
I suppose you have to keep that as a little trophy as well.
Yeah, it's nice to have, definitely to show this. This is the sort of thing we can do. But we've got some 3D printers on site, and yes, they get used for work a lot, but there are some things that they don't get used for work for that it's probably pointless. Key rings and bottle openers and all this sort of thing.
Well, so last question we have now from King Lassie P5. What's the smallest thing you have made?
Smallest thing. I don't know the smallest thing. We do a lot of when you put a Cyclone cluster together, you've got to bolt things together. So we have to make quite small brackets. They're called brackets. That is basically so that you put a bolt in one end and a bolt in another end to tie two things together. You'll see brackets everywhere, really. They can be quite small. That's probably the smallest and simplest thing that we end up doing.
Perfect, brilliant. Well, thank you very much, Simon. That's been great. We've had loads of good questions there.
Yeah, loads of great questions.
Brilliant. I just want to say thank you to King Lassie P5, Holy Trinity. We've got Liam, Elise sending plenty of good questions through, and I'm sure they'll be on with their designs now and start coming up with their own creations.
Yeah, fantastic.
No, brilliant. Great. So thank you very much again. And just a reminder, we need the entries by the 23rd of March, which is next week. We've got engineers all across the UK ready to grade the entries when they come in. If you need any help with that, just let us know. And thank you very much. I hope you've enjoyed the interview with Simon and learning about his career.
Yeah, thank you, everyone. Thank you for your time. And some great questions there, so that's brilliant. Good to see you all interested. So yeah, good luck with your challenge.
Brilliant. Thank you very much, Simon. Take care. Bye, everyone.
Bye.